Well, in this series of videos, I want to go over some examples from Chapter 6.3. And 6.3 is looking at a difference of means. All right, so example 1, let's look at salaries of baseball players. So in the 2012 season, 855 Major League Baseball players. That season, there are 423 pitchers, 432 batters, and other positions. The average salary for pitchers was 3.189. and the standard deviation of 4.288. The average salary for all the batters was 3.683, standard deviation of 5.060. And suppose we take random samples of 30 pitchers and 50 batters at a time, calculate the difference in mean salary between the two groups, and we'll take pitchers minus batters. All right, how would we describe the shape, mean, and standard error of the distribution of means, distribution of difference of means? Pick a different color to write up my answers. All right, so a couple things. The center of the distribution is going to be, if I were to take the average, it's going to be the average of all the pitchers. I'm going to use mu sub p for average of all the pitchers, minus the average of all the batters. And that would be 3.189 minus 3.683, and that's equal to about minus 0.494. All right, the center, or I should say center or mean of the distribution. All right, we also want to know about the shape and standard error. Since the two sample sizes are both at least 30, we have 30 and 50, 30 pitchers, 50 batters. The central limit theorem says the distribution of all the difference in means will be approximately bell-shaped and symmetric. It will look like the normal curve, as long as we have a large enough sample size. And we're going to go with at least 30 or more. And don't forget, we talked about this in class in the past. The actual distribution for the salaries is absolutely not symmetric and bell-shaped. Remember, it's a strong right skew. So recall the distribution of all the salaries is a strong right skew. The central limit theorem says this doesn't matter because the distribution of all the samples will be approximately normal. That's that bell-shaped and symmetric. All right, I guess kind of the power of central limit theorem. Doesn't really matter with the population distribution. Note right here, the population distribution of all the salaries has a very strong right skew, as a lot of things that are money-based are. But the sampling distribution is going to end up being normal. All right, and then the last thing asked on this is the standard error. All right, so I want to look over here at the inferential statistics and formulas. We could compute the standard error with GeoGebra. For this one, I'm going to use this right here. Standard error is the square root of the standard deviation of the first group squared over the sample size plus the standard deviation of the second group squared over the sample size. So if I set that up, standard error is equal to the square root. I'm going to write this out. We're going to have all right, set this up. So I'll have the first standard deviation, 4.288 squared over sample size. So this would be for the pitchers. And then for the batters, we'll take 5.060 squared as my standard deviation, divided the sample size for the batters, which is 50. Put this in your calculator. we're going to get this to be about 1.061, rounded to 3 decimals. All right. All right, next question on this example. How many degrees of freedom would you use in this distribution for a t-distribution if you wanted to do some inferences for the difference in sample of means, which is a confidence interval or hypothesis test? All right, going right here. Difference of means, if we're using independent samples, which we'll talk about paired samples next week. If we're doing independent samples, degrees of freedom is the smaller of the 2 sample sizes minus 1. All right, so degrees of freedom, smaller of 30 minus 1. I'll just write down 29 and 49. Looking at the 2 sample sizes, 30 and 50. The smaller of the sample sizes minus 1. So degrees of freedom is going to be equal to 29 in this case. All right, in the next video, we'll look at Diet Coke and calcium examples.